Hello class and welcome to review day 2. Today we're taking a look at unit 2, which is algebraic expressions or rational expressions. I need another bracket in there. Alright, so let's take a look here. To add and subtract polynomials, remember to collect like terms. To have like terms you have to have the same variable and exponent. Okay, that was the first one. That's a review of grade 9 and 10. Number 2, equivalence of functions. First of all, you have to prove equivalence. The easiest thing, I think, is to simplify each function separately to see if they are equal. Just think about trig identities. That's what you kind of do there. Or prove non-equivalence, where you sub in one value and it gives you two different answers. Just be careful. You may have to sub in a couple to prove it, because one may just be the coincidence where they actually intersect each point. Okay, or you could use a graph, and if you use a graph to prove it, the one function will be exactly on top of the other, and you won't be able to see any different shape. It'll look like it's one right on top of the other. All right, now we're going to be dealing with an example based on that. So here is, does f at x equal g at x, given f at x is this equation and g at x is that equation. So looking at this, ladies and gentlemen, it's A, going to be hard for me to graph some of those. B, it's a long thing to prove non-equivalency, so I'm going to use method A, which is to prove equivalence. So I'm going to simplify each expression. So I'm going to take a look at f at x. And according to f at x, I'm going to remove the brackets and simplify. So it's going to be 2x squared plus 4x. There's a positive sign in front, so I can just remove the bracket. But the second binomial here, you got to be careful. Change the signs to all terms inside. So it becomes negative 3x squared and plus 5x. Okay, collect like terms, ladies and gentlemen. You're going to have negative x squared plus 9x. Let's see what happens with g at x. So for g at x, simplify that. It's going to be negative x squared plus 9x. So do we have the same answers here, ladies and gentlemen? So you say, therefore, yes, f at x does equal g at x. And just remember that x belongs to a set of real numbers with this one. Okay? Good. All right. Number 3, multiplying polynomials. You're either going to use the distributive law or FOIL or both, depending on what you're doing. So let's take a look at this. Just remember, distributive law means whatever's out front you multiply by whatever's inside the bracket. Okay, and then you have distributive law, which is two binomials, first outside, inside, last, and then we've got a squaring a binomial as well. Okay, so let's take a look at doing this. So we're going to have 2x squared plus 2x. I'm going to leave the negative 3x first, out front first, because BEDMAS tells us we've got to deal with the exponents first. So I'm going to use the shortcut where you square the first. So that's going to be x squared. Double the product. So over on a margin, I go 2 times my first term, which is x, times my last term, which is 2. So that becomes plus 4x. You can still expand and use FOIL if you want to. And then square the last. So 2 squared is 4. Okay. Taking a look, before I can do some collecting like terms, I still have to do my distributive law, which means to multiply that out. So I've got 2x squared plus 2x. Now I'm going to multiply through, so I'm going to have negative 3x cubed minus 12x squared minus 12x. Now that I've removed all my brackets, now I can collect like terms. So you should end up with negative 3x cubed minus 10x squared minus 10x. Awesome. Okay, number 4, factoring. Okay, so common factoring, you need the greatest common factor, which is the GCF. Okay, and then if you are using simple decomposition, remember A equals 1. Oopsie, I don't want to cover that up, but A equals 1. So that's why the product is really 1 times C. So it's just C. And the sum is your B value. Okay? That's where you do that work over on the side. Product equals, sum equals, what are my two factors? Okay? Decomposition, ladies and gentlemen, remember you split the middle term and then factor by grouping. We're going to do an example down below of that. And difference of squares, ladies and gentlemen, you recognize difference, meaning subtract sign of two perfect squares. So that gives you the form of a plus b times a minus b. Okay? Those are your different types of factoring. That became useful for us when we were doing the next step, which is simplify rational expressions. So you look to factor and then cancel after multiplying. Okay? And always state your restrictions. Remember, your restrictions is the denominator cannot be equal to 0, right? Okay, so any variable that's on the denominator part cannot be equal to 0. All right, so let's start with an easier one, which is this expression here. Okay, so it says to simplify. Well, I can't do any direct canceling now, but I'm going to look to common factor the numerator. So looking up top, I can see a common x, so I'm going to be left with 3y minus z. In the denominator, I see a common factor of 3, so I'll be left with 3y minus z. Now that I've factored, and these are multipliers, I can now cancel it out. So what does this mean? That means that x simplifies to x divided by 3, and we have to remember our restrictions. Okay, so the denominator cannot be equal to 0. Okay, if I look for my simplification here, 3 can never change, so it stays as 3. But in here, I know that 3y minus z cannot equal 0. So I just move one term to the side, so it's going to be 3y cannot equal z, or z cannot equal 3y. All right, remember that when your rational expression, we have to simplify, those are easier when you then having to add or subtract rational exponents. So I'm going to preface that write small for this example, or do 2 lines, started on the left side and then go to the right side, because this is going to take us a little time, ladies and gentlemen. Be patient, we can do it. When you add and subtract, you got to factor, then you got to find the lowest common factor, then you add and subtract. And after, don't forget to state your restrictions. Okay. So I'm going to start way over here and see how much room I can save here. Looking at the first binomial here, I don't see any factoring in that, so I'm going to leave that as this. Looking in my denominator, hopefully, ladies and gentlemen, you realize that's a difference of squares. So that's going to be 2x plus 1 and 2x minus 1. Okay, hopefully that's all right for you. Okay, then we've got a subtract sign. Looking at the numerator, the second fraction, I don't see any simplification there. So leave that as is. And then I'm looking at the denominator here, ladies and gentlemen. And hopefully you realize that this is what's called a perfect square. What do you mean by that? Well, let's take a look. If you didn't know that it was a difference of squares, you would have to do what's called decomposition. Or sorry, if you didn't know it was a perfect square, I said that wrong. Perfect square. Okay, so taking a look at decomp, if I take a look at this, I notice that if I have to factor, I notice a does not equal 1. So when I do that, product equals a times c. Okay, and that in this case it's 4 times 1, which equals 4. And the sum is b, and b equals 4. So what two numbers multiply to 4 and add to 4? You're going to know that that's 2 and 2. So if you don't recognize that as being equal, then you say, okay, here's how I do my decomposition. I'm going to move down a little further. So I'm just going to write the question out a little bit one more time, and then I'm going to show you how to do decomposition or review. Remember, for decomposition, you split the middle term. So it's going to be 2x plus 2x. The first and last terms stay the same, so it's going to be 4x squared plus 2x, and then plus 1. So you now have 4 terms, and just remember, folks, I've kept that balance because 2x plus 2x does equal 4x. And now what we need to do is factor by grouping. So what's common in the first 2 groups? You're going to see 2x, and you're going to be left over with 2x plus 1. What's left in the last 2 columns? Well, hey, the only thing I see is a 1, so plus 1, and you're left with 2x plus 1. When you factor by grouping, your common binomial goes first, so 2x plus 1. And your leftovers is what's left over, so it's 2x plus 1. What do you realize, ladies and gentlemen? Those are the same, so it's 2x plus 1 squared. Whew, that took us a little while. See me if you don't know the shortcut and you want to know the shortcut for that. I'm just not going to spend time in this lesson on it. Okay, so now that we've factored, ladies and gentlemen, now we've got to come up with what's called the lowest common factor here. So lowest common factor is going to be, notice that this one of these is repeated in here, so we don't have to include it twice. So we're going to deal with this factor, okay, and this factor. Okay, so my lowest common factor equals 2x minus 1 times 2x plus 1 squared. Okay, or you could write that out twice, it's still okay. So what I'm going to do, folks, is now I've got to figure out what I'm going to do to change things about, okay, to make this equal. So if I want to have my denominator with the same lowest common factors, I got 2x minus 1 times 2x plus 1 squared. Currently, what's already existing there is 3x plus 2. But what do we have to multiply it by? Which is missing from here to here? Well, you're missing a 2x plus 1, so I'm going to times it by 2x plus 1. Okay, subtract. Second fraction, what do I already have existing? I already have 2x plus 1 squared existing, and what factor do I have to make it for the lowest common factor? I need to add my 2x minus 1, okay? So I already have on the numerator 2x minus, oh, sorry, my fault. Back that up. I'm just going to change the color too. Let's be colorful today. So I already have 2x minus 1, and I have to add what I have added to, or I have to multiply what I multiplied to the denominator, which is 2x minus 1. Phew! That looks hard, but you know what? The good news is I can do one straight line because now I've got my greatest common factors all together. Sorry, my lowest common factors all together. So I'm going to go 2x minus 1 times 2x plus 1 squared because the denominators are both the same. All I have to do now is to remember, how do I simplify this? And you're going to use your FOIL. First, outside, inside, and last. So let's do that. You should have 6x squared plus 7x plus 2. I just combined the, back that up, sorry. I'll back it up for you guys. Okay, so doing FOIL first, outside would be 3x, inside would be plus 4x, and then minus 2. Okay, don't forget we have a negative sign out front, so we still need a bracket in here when we're doing FOIL. So it's going to be 4x squared minus 2x minus 2x plus 1. All right. Working our way through this. I know it takes a little bit of room. We're going to do it. I always like to do the denominator first, guys. Okay. And we're going to collect like terms in the beginning here. 6x squared plus 7x minus 2. I don't mind if you go right away to that. That doesn't matter to me. That's what I did myself. And then collect like terms inside the bracket first. So it's going to be 4x squared minus 4x plus 1. We still have to do... Okay, I'll be okay. Okay, so, sorry I got a meeting, blah. I wish I could stay here with you guys. Because you know how much I love staff meetings. Have you heard? Anyway, life goes on. All right, so let's simplify. We got to remember, this is a negative, so you got to multiply it through or times everything by -1 or change the signs of everything in that bracket. Okay. We've now been able to remove the brackets. And the last line, woohoo, we're going to make it through. Collect like terms. So I put the denominator down first. Okay, here we go. Last line, we can do it. 2x squared plus 11x plus 1. There's the simplification. don't forget that we have to deal with our restrictions. All right, so our restrictions are, looking at our denominator, okay? We know that 2x minus 1 cannot equal 0, so let's solve for that. So 2x cannot equal 1, so x cannot equal 1 over 2. Okay, and the other one, ladies and gentlemen, is that we've got 2x plus 1 squared cannot equal 0. Let's take the square root of both sides. You know that 2x plus 1 cannot equal 0 because the square root of 0 is 0. 2x cannot equal negative 1. X cannot equal negative 1/2. So there's your two restrictions there. All right, moving on, ladies and gentlemen, to multiplying and dividing rationals. Okay? So when you're multiplying, just remember to multiply the tops and multiply the bottoms. Okay? Divide means to invert or flip the second fraction and multiply. Start by factoring and look to cancel first, ladies and gentlemen, okay? Then multiply, and don't forget to state your restrictions. Remember that we've seen a little trick recently that if you see two binomials and they're both opposite signs, that you can multiply one by -1 and cancel them out, okay? All right, let's try this example here. Okay, so I've got my first fraction here. So I've got x divided by x minus 1. And then I've got to divide by sign, so I have to do what? Times it. I've got to invert and flip that fraction so I can multiply. So now my numerator becomes my denominator. And my denominator becomes my numerator. All right. Now I'm going to look to factor. Well, my first fraction is in factored form. There's nothing I can simplify, but I can simplify the numerator and the denominator in my second fraction. Okay, so this first one is a simple trinomial. If you're not sure, product equals -2, sum equals 1. What two factors would that be? It's going to be 2 and -1. So it's going to be x plus 2 times x minus 1. Looking at the denominator, that's a simple common factoring, so 3 times x plus 2. Okay, now I look to simplify. I look to cancel or cross out. Okay, so remember, folks, that if you're reducing, it's within the same fraction. So here's an example of reducing the x plus 2. And if you're going to cancel, as long as you've got one numerator, one denominator, and it's a factor, meaning multiply, you're okay. So what does this simplify down to? This simplifies down to x divided by 3. Don't forget your restrictions. And our restrictions are that x minus 1 cannot equal 0, and that's from this first denominator right here. Okay, so x cannot equal 1. That's the first one. The second one, you have to be careful, is from the original question. That's still the divide by sign. So that tells us that we already have the x minus 1, but we need the x plus 2 part. So x plus 2 cannot equal 0. So x cannot equal -2. Okay, and then you also check, ladies and gentlemen, for once it's been flipped, if the fraction has a restriction there, it's the same one, okay, -2. So ladies and gentlemen, just remember that if you've got a divide by sign, you've got to look at both the numerator and the denominator of the original fraction. Okay, it just happens that those are repeats. Okay. All right, so just remember, when it's a divide by fraction, you have to look at both the numerator and the denominator for your restrictions. Okay, graphs of rational functions. Ooh, remember we talked about wholes occur where the factors canceled out. So if you go back here, ladies and gentlemen, notice that we canceled out x plus 2. Okay, and we canceled out x minus 1. So if you solve for those, the wholes would occur at -2 and at +1. And vertical asymptotes are where the factors, they don't cancel. And we didn't have any in this case above because all the factors got canceled. Okay. All right. I apologize. We have the x still there. Okay. All right, so here we go. Describe this graph here. Okay. So what we need to do is, based on this example, luckily it's in simplified form. So what do I notice I can cancel here? I can cancel out those two, which is cancellation. So what does that tell us? Factors canceled. So that's x plus 1 equals 0. Solve it. So x equals -1. And because it canceled, ladies and gentlemen, that's a whole. Okay. Factors that don't cancel, which are these ones. Okay. So x minus 3 equals 0. So x equals 3. And the other one, that's a bad looking arrow. There we go. X minus 4 equals 0. So x equals 4. These two are both what we call vertical asymptotes. Okay? And that's at x equals 3 and x equals 4. Okay? Just to reiterate, guys, I noticed we had a factor of 3 up here, but it's in the numerator, so we don't worry about it, okay? It's the ones that are in the denominator, okay? Because it's based on your restrictions. All right. Hey, we made it through day 2. Woohoo! Here's your homework, page 206, numbers 5 to 8, 31, 32. And again, check out unit test number 2. All right. Have a great day, folks. Come and see me if you need any help.